Greetings, math people, and welcome to another round of an interesting integral. Today we're looking at an integral from the MIT Integration Bee. This is the 2006 Integration Bee. This is number 5 or 6, I believe it was. And actually, when I did the integral, it actually was a fairly routine integral. So let's go ahead and step into it.
Specialize in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.
So here's our integral here. And so we're integrating a 1 minus sine over 1 plus sine. 1 minus sine x over 1 plus sine x dx. And the natural intuition is the right move to do. So when you see something like this and you think of simplifying trigonometric expression utilizing trig identities, your first thought is either to multiply the top and bottom by 1 minus sine x or to multiply the top and bottom by 1 plus sine x. And the best thing is to multiply top and bottom by 1 minus sine x. Why? Because that's going to make this denominator a 1 minus sine squared x, which would then turn into cosine squared x. And so it condenses this denominator down to just one term. And however many terms may be at the top, you can just divide each term by the denominator. And hopefully that's a nice simple form that we can easily integrate. So that's the route to go. So what I'm going to do is I'm going to multiply the top and bottom by 1 minus sine x. So on the top, I'll get 1 minus sine x squared. And on the bottom, I'll get 1 minus sine squared x. And of course, we're integrating this guy. Okay, so when I first did it, I know this is going to turn to cosine squared x. I thought about perhaps leaving this guy like this without multiplying it out and maybe doing some type of u substitution, but that really didn't work. So it's best to multiply this out and to turn this into cosine x. So I'm going to go ahead and multiply this out. And this is going to be sine squared x minus 2 sine x plus 1. And that, of course, is going to be over cosine squared x. And we're integrating this puppy. So there we have a nice guy. And now we can just divide everything by cosine squared x. And it actually divides quite nicely and allows for easy integration, actually. This was actually a problem, another problem that the contestants actually couldn't solve. It's a little bit surprising. A lot of them in their answers when the time ran out, they were doing a natural log substitution. So it's kind of surprising they didn't get this one because it kind of naturally goes with what you would do to simplify a trigonometric function utilizing trig identities. But nonetheless, let's go ahead and divide everything by cosine squared x. And we'll have sine squared x divided by cosine squared x. That's tan squared x. That's nice. And we'll have minus 2 sine x divided by cosine squared x. So if you just take sine over cosine, that's tan, and then you have another cosine x at the bottom, so that's secant tan. So it's minus secant x tan x. That's even nicer. And then, of course, 1 divided by cosine squared x is just secant squared x. And that's real nice. So that guy is looking pretty darn good there. So that's a nice little problem there. The only part these are just basic integrals. These come from basic derivatives. The only guy that's a little bit interesting is this guy, but he's not all that interesting because we can utilize our Pythagorean identities and we can rewrite this guy as secant squared x minus 1. So the tan squared x, that will turn into secant squared x minus 1 minus 2 secant x tan x, excuse my handwriting, plus secant squared x. All right, and so you can see here I'm going to have 2 secant squared x's, and I'll have a minus 2 secant tan and a minus 1 all things that are very easy to integrate. So let's go ahead and write that and then finish up the problem. This one actually went pretty quick. So just take a look at what we're going to have. So we'll have 2 secant squared x minus 2 secant x tan x and minus 1 dx. So again, it's pretty much done. These are all elementary things to integrate. And so the integral of 2 secant squared x is 2 tan x. And the integral of 2 secant tan is 2 secant. And the integral of 1 is x plus some constant. There it is. As we say in the business, that guy was easy money. So here we are again with another episode of An Interesting Integral. Hope you enjoyed it. We'll see you next time.
Specialized in science and mathing, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe-to-toe, impeccable, splitting your back, son, simple as addition and subtraction, black thought, the infinite relax one.